For all of human history, gold has been a symbol of wealth, power, and beauty. We fought wars over it, built monuments with it, and adorned ourselves in its radiant glow. But have you ever wondered where gold truly comes from? Not from a mine, but how its atoms were forged. The atoms in your wedding ring have a story far older and more violent than any human tale. For centuries, this was one of science's greatest mysteries. We knew gold wasn't made on Earth. Our planet inherited it. So, what cosmic event could create something so heavy and precious? Stars are the universe's element factories, fusing lighter atoms into heavier ones, but only up to a point. When it comes to gold, a normal star just doesn't have what it takes. The search for gold's origin led us to the most extreme places in the universe, where physics is pushed to its limits. The answer, when it came, was more spectacular than anyone imagined. The collision of ultra-dense dead stars, producing a flash of light called a kilonova. This is the story of how we caught the universe in the act of making gold, and how that story connects the cosmos to the ring on your finger. To understand where gold comes from, we first need to understand where it doesn't. Stars are giant balls of hot gas, mostly hydrogen, fusing atoms in their cores to create heavier elements. This process, called stellar nucleosynthesis, builds up elements like carbon, oxygen, and silicon. But there's a limit. Fusion in stars can only create elements up to iron. Fusing iron doesn't release energy, it consumes it. When a massive star's core fills with iron, it collapses and explodes as a supernova. For a long time, scientists thought supernovae could make gold, but the energy and conditions just aren't right. The stellar forge, as powerful as it is, has its limits. Elements heavier than iron, like gold and platinum, require a different, more violent process. The question remained: what cosmic event could create the universe's heaviest treasures? The answer would take us beyond the life and death of ordinary stars. It would require us to look for something even more extreme. The search for gold's origin was far from over. The universe had one more secret to reveal. With stars ruled out, astronomers turned to supernovae, the explosive deaths of massive stars. Supernovae are powerful, scattering elements across the galaxy. Scientists thought these explosions could create gold through the R-Process, where atomic nuclei rapidly capture neutrons. For decades, this was the leading theory. But as computer models improved, problems emerged. Supernovae didn't seem to create enough of the right conditions for the R-Process. Observations of old stars showed plenty of iron but little gold, suggesting supernovae and gold production weren't always linked. The numbers didn't add up. The evidence pointed elsewhere. The universe was hiding its gold factory in an even more exotic and violent location. The search continued. To solve the mystery, scientists needed a new way to observe the universe, not just with light, but with gravitational waves. Einstein predicted that massive objects in motion would create ripples in spacetime. Gravitational waves. These waves are generated by the universe's most violent events, like colliding black holes or neutron stars. Detecting them required incredible precision, measuring changes smaller than an atom's nucleus. Enter LIGO, the Laser Interferometer Gravitational Wave Observatory. Two giant detectors in the US used lasers to sense the tiniest distortions in spacetime. If a gravitational wave passed through, it would stretch one arm and squeeze the other, creating a detectable signal. After years of effort, LIGO was ready to listen for these cosmic whispers. This new tool would soon provide the crucial clue needed to solve the mystery of gold. It was a revolutionary way to hear the universe's most extreme collisions, and it would change our understanding of the cosmos forever. The stage was set for a discovery that would rewrite the story of gold. The universe was about to reveal its secret. On August 17, 2017, LIGO and its European partner Virgo detected a new kind of signal. Unlike previous black hole mergers, this one lasted 100 seconds, a death spiral of two neutron stars. Just 1.7 seconds after the gravitational wave ended, NASA's Fermi telescope detected a burst of gamma rays from the same region. For the first time, two different signals from the same event, gravitational waves and gamma rays. Astronomers worldwide raced to find the afterglow. Within hours, a new point of light appeared in galaxy NGC 4993, 130 million light-years away. This was a kilonova, an explosion less powerful than a supernova, but far more brilliant than a nova. Telescopes watched as the light changed from blue to red over days. The color shift revealed the creation of heavy elements. By analyzing the spectrum, astronomers could see gold and other precious metals being forged. The mystery of gold's origin was about to be solved. For the first time, we witnessed the universe making gold in real time. The cosmic detective story had its breakthrough. The Kilonova was the smoking gun. To understand why neutron star collisions matter, we need to know what neutron stars are. They're the collapsed cores of massive stars, crushed into balls of pure neutrons, only about 20 kilometers across, but more massive than our sun. A teaspoon of neutron star material would weigh billions of tons. Sometimes, two neutron stars orbit each other in a binary system. Over millions of years, they spiral closer, emitting gravitational waves. Their final collision is unimaginably violent, ejecting neutron-rich material into space. This is the perfect environment for the R-Process, the rapid neutron capture that creates heavy elements. Neutron star mergers are the universe's ultimate element factories. Here, the heaviest treasures are born. The GW170817 collision created a kilonova, a cosmic explosion where gold is forged. Neutron-rich material was hurled into space, triggering the R-Process. Atomic nuclei rapidly captured neutrons, becoming heavier and more unstable. As these nuclei decayed, they transformed into stable elements like gold and platinum. The fading red glow from the kilonova was the signature of this radioactive decay. Scientists estimated that GW170817 produced thousands of Earth masses of heavy elements, including up to 100 Earth masses of gold. This was definitive proof. Gold is made in the collision of dead stars, not in living ones or supernovae. The rarity of these mergers explains why gold is so scarce. Some old stars have iron but no gold. They were enriched by supernovae, not kilonovae. The kilonova was the missing link, the perfect cosmic cauldron for the heaviest elements. For the first time, we saw the universe's gold factory in action. The story of gold was finally complete. The glow of GW170817 was the light of freshly forged treasure. But how does gold from a kilonova end up on Earth? The debris from neutron star mergers drifts through the galaxy, mixing with clouds of gas and dust. These enriched clouds form new stars and planets. Our Sun and Earth were born from such a cloud, inheriting gold forged in ancient collisions. Most gold sank to Earth's core, but some was delivered to the surface by asteroid impacts billions of years ago. These asteroids acted as a final cosmic delivery service, peppering Earth's crust with precious metals. The gold we mine today is a relic of this cosmic journey. Every piece of gold is a messenger from the stars. The next time you see a gold ring, remember its extraordinary journey. Its atoms were born in the cataclysmic merger of neutron stars, not on Earth or in our Sun. That gold traveled across the galaxy, became part of the cloud that formed our solar system, and was delivered to Earth by ancient asteroids. Every atom of gold is a relic of a cosmic collision, a tangible link to the universe's most extreme events. The beauty we cherish is a direct result of the universe's most violent physics. We are, in a real sense, wearing the remnants of dead stars. The discovery of GW170817 was a landmark, showing how new tools can solve ancient mysteries. Science is never finished. The universe may have more ways to make heavy elements. For now, we can look at gold with new wonder, a messenger from a distant time and a violent place. It connects the deepest mysteries of astrophysics with the object on your finger. The universe is full of such stories waiting to be discovered.